Hello student, today I am going to explain or discuss a very important topic, pin diagram of 80868088 microprocessor. This topic has been requested by many students, so I am going to explain microprocessor 8086 pin diagram. Okay, let us start the topic, pin diagram of 8086. The topic, minimum and maximum mode, has been covered under this section. One thing I would like to say that 8086 microprocessor having both minimum and maximum mode. I will explain it one by one, so you will have to concentrate on my lecture word by word. Okay, I will explain each and every pin one by one. At the last I will explain pin number 33, which is known as minimum and maximum mode. This is very important pin regarding 8086, by which we can switch microprocessor at minimum and maximum mode. As you can see that in small brackets from pin number 24 to 31 are in under minimum modes, and out of small brackets are in maximum mode. Okay, let us start the diagram of 8086, okay, which is shown in the lecture. Okay, there are two ground pin. Okay, there is two ground pin and one VCC pin. Now it is very important that is address and data pin. There are 16 data pin and 20 address pin. From AD0 to AD15 are being multiplexed, and rest of pin are free from multiplexing, which are start from A16 to A19, as you can see in the diagram. Okay, now let us start from pin number 9 to 16. AD0 to AD7, 8086 or 8088 address data bus line compose the multiplexer address data bus of the 8086 and contain the rightmost of 8-bit of microprocessor address of input output port. Whenever ALE means address latch enable is active high or data line. Whenever ALE is active low, these pins are their high impedance states during the hold acknowledge. And the pin A8 to A15, the 8086 address oblique data bus line composed under multiplex address data bus of 8086. This line contain address bit A8 to A15. Whenever ALE means address latch enable is logic 1, the data bus connects A8 to A15. These pin enter high impedance states whenever hold acknowledge occur. Okay, at the last, the rest of address pin A16 to A19, pin number 35 to 38, the address oblique status bus are multiplexed to provide address signal A16 to A19, and also stated bit S3 to S6. These pins also attend a high impedance states during the hold acknowledge. The status bit S16 always remains 0, and bit S5 indicate the condition of instruction flag or interrupt flag bit, and S4 and S3 show which segment assessed during the current bus cycle. The truth table of S4 and S3 is shown in figure, as you can see. If there is 0 0 combination, there will be occur extra segment. If 0 1 stack segment, 1 0 code segment, and at the last 1 1 data segment. Okay, next I will move another pin number 32. RD bar. Whenever the read signal is logic 0, the data bus is to read data from the memory or input output devices connected to the system. Okay. Similarly, pin number 22, name as ready. This pin is control to insert wait state into the timing of the microprocessor. When the ready pin is placed at logic 0, please concentrate, at the logic 0 label, the microprocessor enter into wait state and remains idle. And when the ready pin is placed at logic 1 label. Okay, let's move with the pin number 18, INTR. INTR very important because it is known as interrupt reset या interrupt requested pin. Okay, the interrupt request is needed to request a hardware interrupt for INTR held high. When interrupt flag is equal to 1, the microprocessor 8086 enter an interrupt acknowledge cycle after the current instruction has been completed. Okay, let's move with pin number 23, test bar. Okay, a test pin in on input that is tested by the wait instruction. If test bar is logic 0, the wait instruction function as a knob. As a knob, as you know, NOP instruction known as the no operation. Okay, if test is logic 1 or active high, then the wait instruction wait for the test to become logic 0. This pin is mostly connected to the 8086 or 8088. Okay, next move with very important pin number 17, NMI known as non-maximal interrupt. Okay, the non-maximal interrupt input is just similar to INTR, except that the NMI non-maximal interrupt does not check to see if interrupt flag bit is logic 1. Whenever NMI is activated, this interrupt use interrupt vector 2. Okay, let's move with pin number 21, reset. As you know, reset is very important for the any microprocessor. Okay, let's start with the reset. The reset input makes the microprocessor to reset itself if this pin 0 will be held high for the minimum of 4 clock period. If 8086 or 8088 microprocessor is reset, it begins executed instructions from the memory location like FFF0H and disable features interrupt by clearing the IF flag. IF flag stand for interrupt flag. Okay, let's move with another important pin, CLK. CLK means clock. Okay, the clock pin will provide the basic timing signal to the microprocessor. The clock signal must have a duty cycle 33% to provide proper internal timing for the 8086 and 8088. Okay, at the beginning I should explain the ground and VCC. Okay, now let's start with ground. Okay, ground. Okay, there is two ground signals. One is the pin number 1 and second is pin number 2. The ground signal is a very simple. Ground means very ground. The ground supply to the microprocessor, and pin number 40, VCC. VCC means the power supply input provided as +5 volt. Okay, and at the last pin in this video lecture, BHE bar oblique S7. Okay, BHE means bus high enable. Okay, the bus high enable pins will help you 8086 to enable the most significant data bit D8 to D15 during a read or write operation, and the state S7. S stand for the states. Okay, the states of S7 is always a logic high during during when bus high enable pin will active high. Okay,